Hey y'all. I wanted to make a quick video for you with another example of graphing rational functions. Um, Again, sorry to put so many videos for this module too, but I want you to have resources in case you need them. You might not need these resources, and that's fine, but I want them to be here in case you need them. All right, so we didn't get to this one in class, so I want to give you an example of number 2. I want to graph the rational function negative 3x squared minus 15x all over x squared plus 7x plus 10. Okay, so to start here, we need to find our holes, our vertical asymptotes, and our x-intercepts. To do that, we need to factor everything here. I'm going to start with my numerator here, and I'm going to factor out a common factor because I have a negative 3 that will come out of both pieces and an x. So I'm going to take a negative 3x out there, and I'm going to get x plus 5. Okay, so that's factored on top. And then on the bottom, this is a trinomial, so I'm looking for magic numbers. My magic numbers are going to multiply to 1 times 10, that's 10, right? That's AC. And those same two numbers need to add to 7, my B value. All right, the two magic numbers that multiply to positive 10 and add to positive 7. Yep, you got it. It's positive 5 and positive 2. Because my leading coefficient here is a 1, I can just pop those magic numbers into parentheses with x's. I can take my shortcut. Okay, so now that I have this factored, we can look and see I have something in common. This x plus 5 would cancel. Because I have some cancellation, that's going to create a hole at the x value that makes it 0. So if x plus 5 is equal to 0, that means x equals negative 5. So I have a hole at x equals negative 5. Now that I've made note of that, I can go ahead and do the canceling and simplify it out. And we will use negative 3x over x plus 2 from here on. Okay, so now that we know that our hole is at x equals negative 5, a hole is an ordered pair, so we need our y value. To get the y value of your hole, you're going to plug that x value into your simplified function here. So I'm going to get negative 3 times negative 5 over negative 5 plus 2, which is going to be 15 divided by negative 3, and that's negative 5. Okay, so I have a hole at the ordered pair negative 5, negative 5. All right, so I have a hole. Now for my x-intercepts and my vertical asymptotes, we'll look at our simplified function here. Where the bottom is equal to 0 gives us our vertical asymptotes. Where the top is equal to 0 gives us our x-intercepts. So we're going to have a vertical asymptote wherever x plus 2 equals 0, which is at the vertical line x equals negative 2. So that's my vertical asymptote. And for my x-intercepts, I'm going to have x-intercepts anywhere negative 3x is equal to 0. Divide both sides by negative 3, and you get x equals 0 is our x-intercept. And that means 0, 0 is a point on my graph. The x-intercept means where y is 0, so that's where I got this 0 from. We solved for that first 0, and the y being 0 comes from the definition of an x-intercept. Okay, so we have our holes, our vertical asymptotes, and our x-intercepts. And then finally, we need to find any horizontal or slant asymptotes. To do that, we're going to look at our end behavior fraction. Again, end behavior fraction is leading term on top over leading term on the bottom. The biggest bully on the playground on top. Oh, and before we do this, for your end behavior fraction, you can either use your original or your simplified version for this. You're going to get the same thing either way. It really doesn't matter which you use. So I'll just go with the original, right? So let's look at our original here. So my leading term on the top of my original, my biggest bully on the playground up there is negative 3x squared. And the biggest bully on the playground on the bottom is x squared. All right, if we simplify that, negative 3x squared over x squareds, the x squareds cancel, and I'm left with negative 3 over 1, or just negative 3. Okay, so our end behavior fraction simplifies to negative 3. That means my original function acts like y equals negative 3 at the ends. Well, y equals negative 3, that's a horizontal line. This means I have a horizontal asymptote at y equals negative 3, right? If your end behavior fraction simplifies to a number, y equals that number is your horizontal asymptote. And notice if you had used your simplified version, your end behavior fraction would be negative 3x over x. And again, that would simplify to negative 3 and you'd get the same result. Okay, so let's put all of this on a graph. All right, so I'm going to start with my asymptotes here. I've got a vertical asymptote at x equals negative 2. I'm just going to put some lines on here. All right, just to get something to start with. Okay, now let's put our asymptotes on there. I've got a vertical asymptote at x equals negative 2. So there's my vertical asymptote. I have a horizontal asymptote at y equals negative 3. So there is my horizontal asymptote at y equals negative 3. And then I have my hole at negative 5, negative 5. So negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. I have a hole there. Again, a hole is an open circle that represents a missing point there. But again, our function has to go through it. So it's an open circle, but we're going to use that as one of our points when we go to graph this. And then our x-intercept is the point 0, 0, which is right here. And so there is my x-intercept. Okay, so now to finish graphing this, we're going to need at least 2 points on either side of our vertical asymptote. Right now we have 1. So we just need to get another point on either side of our vertical asymptote. There's really nothing magical about the x values you pick, so you can really pick anything that you like. So over here on the right, I'm going to pick x equals 1. And so when I take x equals 1 and plug it in, use your simplified version to plug it in. And so I'm going to get that y equals negative 3 times 1 over 1 plus 2, which means y is negative 3 divided by 3, which is negative 1. So I know the ordered pair x equals 1, y equals negative 1 is a point on my graph. So I'll go ahead and put that one on. And then I need another point on the left side of my vertical asymptote. How about x equals negative 3? Again, nothing magical about that. I just picked my favorite x value to the left of that vertical asymptote at x equals negative 2. So if I plug in x equals negative 3, I get that y is negative 3 times negative 3 all over negative 3 plus 2. And that is a 9 on top, a negative 1 on the bottom. And that means I have a y value at negative 9. So I'm going to go to negative 3, and I'm going to have a point all the way down at negative 9. So this is going to kind of be one in my way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to be at negative 3, negative 9. My point is like right here. I'm sorry that this is going to be right in the middle of my work, but it's kind of what happens sometimes. Okay. Now, from here, to finish our graph, you're going to start at one of your points, connect it to the other one, go through it, and then go to the asymptote that you're heading toward. And again, we're going to reverse that. I'm going to start at the other point, connect it to my original, go through it, and then keep going toward the asymptote that you're heading toward. And we'll do the same thing over here. Start at your point. I'm going to head up to my hole and connect it, go through the hole, and then go to that asymptote that is there. And we'll go to the other side as well. You'll start at your hole, connect it to the other point, keep going, and then go to your vertical asymptote, because that's where I was headed. So that is what my graph looks like for number 2. And again, nothing magical about those x values. I just picked my favorite. You can really pick any x values you want. All right. Hope that helped. And then I also wanted to just go through getting information from a rational function graph. So if I'm given a graph of a rational function, we'll be asked to identify some things. So first of all, this asks me to identify the x-intercepts and the y-intercepts on this graph. Okay, well, x-intercepts, those are the places where my graph crosses the x-axis, which is the line y equals 0 here. Where does this graph cross the y-axis? Yeah, it doesn't, right? The y equals 0 is a horizontal asymptote for us, right? And so this function never touches or crosses that horizontal asymptote. That means I have no x-intercepts. No x-intercepts here. You can just write none. And in ALEKS, it either tells you what to type in there or there's a button that you'll click for none. And then for the y-intercepts, identify our y-intercepts. Those are the places where we cross the y-axis, which is right here. Where does our function cross the y-axis? Yep, right here at this point. That is our y-intercept. So a y-intercept is an ordered pair. Our y-intercept happens at negative, 0, -1, sorry. Our x-coordinate is 0, our y-coordinate is -1. Okay, so that is our y-intercept. And then identify all vertical and horizontal asymptotes. So our vertical asymptote, where's our vertical asymptote? Yep, it's dotted in right here. A vertical asymptote is a vertical line, so this needs to be in the equation of a vertical line, which is x equals some number, and our vertical asymptote goes through x equals 5. And then how about our horizontal asymptote? Yep, horizontal asymptote we identified here before. It is the x-axis, which is a horizontal line that has the equation y equals, and this horizontal asymptote goes through y equals 0. And then finally, our domain and our range. The domain of this function is any x value that has a y value that goes with it. So we will be looking at the x coordinates, the x values that have partners. So I will be kind of looking at what x values have partners here. This arrow is going to keep covering all the x values over there. And this whole section here covers all of these x values, right? All of these x values have partners, which is our points on this line. And because this x equals 5 is a vertical asymptote, this function is going to keep going and get really, really, really close to x equals 5, but it's not actually going to get there. So I'm not going to have a y value at x equals 5, but I am going to go as close as I possibly can to it. And then this section here, again, this arrow is going to cover all of my x values from here over, and every point on here covers all of this stuff. Because x equals 5 is my vertical asymptote, this is also going to just get really, really close to it. It's going to get as close as possible without actually touching it. So it's going to cover all of that stuff, which means our domain goes from negative infinity all the way up to 5, not including 5. And then I'm going to union that with everything on the other side, which is 5 to infinity. It's everything except that x equals 5. And now let's look at our range. Our range is all of the y values that have partners. Okay, so y values that have partners, again, this section of the graph right here, this arrow covers all of the y values going down to negative infinity, and then this part covers all of these y values, and then this arrow means it's going to get really, really, really close to y equals 0, but it's never actually going to get there. So again, I'm going to have an open circle here at y equals 0. I'm not going to have an x. I'm not going to have an x value there. So that's not going to be included in my range. But all of these pieces are covered by that section. And then this section on the right here, again, this arrow is going to cover everything to negative infinity. And all of this stuff is covered up to y equals 0. So that means that my range is everything from negative infinity up to 0. 0 doesn't have a partner, so I'm not going to include it. And then I don't have anything above 0. So that is it for my range. All right. I hope that was helpful for you. Again, module 2 homework is due on Friday. Let me know if you have any questions, and I will see you next time.